Hey guys, it's been about a month since I posted my last video, and I've been working in the background on Nebula V2, my next design after the Nebula V1, which I crashed about 2 months ago. And this video here is the first part in the build log where I'll be doing the start of the fuselage and the rear landing gear. Here's a cross section of the fuselage design. It's pretty simple construction. It's just made out of 5mm Adams Ready foam board, and then I'll end up fiberglassing the outside of it when it's all put together. Here I'm cutting out some side hatches that I'll use to be able to access the internal payload. I wanted this aircraft to have a lot more internal volume for carrying either better telemetry, camera gear, or larger battery packs. Here I'll start cutting out the internal baffles, which are used for reinforcing the payload bay, along with the portion where the fuselage splits in half. This is the primary box structure, which is responsible for distributing the load between the wing mount and the rear landing gear. The rear landing gear are attached on the bottom right under the second plate on the bottom of the box structure, and it reinforces around where the external hatches are for accessing the payload bay. So the fuselage is designed to split into two parts so I can transport it inside my car, and the main issue with that is making sure it's strong where the two parts come apart. On the bottom here I'm installing a carbon fiber spar with Gorilla Glue that slots into the back portion of the fuselage, And you want to make sure this is strong, that way the tail surfaces have adequate control. Because if the fuselage ends up being a bit weak and flexy, then you might end up losing control of the rudder and the elevator. But along with this joint, there's going to be two on either side and then another one up on the top. Here are the front and rear portions of the fuselage without the top and without the carbon fiber added to the sides. The front and the rear aren't quite 100% flush with one another, but I plan on putting some sort of putty in between after I fiberglass it to fill up those holes. Here you can see into the payload bay. I included a little hatch taken out of the bottom to point cameras downwards, and here's a size comparison against the modulus. So starting on the landing gear, I wanted to go with a primarily aluminum construction, and I was shooting for about 3.5 kilograms all-up weight for the entire aircraft, so I was testing it under load at about 6.5 kilograms. There's a little bit too much deflection, and I'll end up addressing that later. But here I'm just forming the metal and cutting out the holes for the actual wheel axles to go through. So in simulating the landing gear, there's a little bit more deflection than what I wanted, even though the total load wasn't approaching the yield strength for the landing gear. I think that's because 6061 aluminum is a little bit softer and yields more than 2024 aluminum, which was what I was originally planning on using, but it ended up being a bit too expensive. So I planned on accommodating this by having the inside aluminum as a core and then fiberglassing the outside to add rigidity to the structure. I went with this approach because I'm not too worried about the actual landing gear yielding themselves, at least from the results of the simulation. But what I am worried about is deflection being too high and then causing some instability on ground roll, primarily on landing, because I'm not too concerned about unstable ground roll on takeoff. doing one layer of 3-ounce fiberglass on the top and the bottom, and then later I'll put another layer on the middle section of the landing gear on the bottom. I don't want to put too many layers because I still want there to be some springiness in the landing gear to help soften impacts, but I do want some of the deflection to go away. Not going to go too much into the nose. I'll cover that more when I do the front landing gear, but the nose is 3D printed in 3 segments and they'll be attached with fiberglass and some foam core. Here I'm just test fitting everything together to see how it fits and see what it looks like to get an idea of what the final product will be. I'll try to get the follow-up video out as soon as I can, but in any case, thanks for watching.